Hello, Heifel. O'Day. Can I just call you Heifel? All right. Well, see, you were showing something there that is an object moving through a field, as if the field has a set thing. You're thinking of the gravitational field. Now, there's the electromagnetic field, which is the domain of quantum mechanics, and underlying that, unifying all these electromagnetic and related domains as particle physics, is the quantum field. So there's the quantum field. And on the other hand, there is the gravitational field. It has something to do with time, right? That's why its relativity is all about time, also mass and space dimensions. So it's about time and space. And these have not been correlated. Now, an object, what appears to be an object, is an electromagnetic phenomena, and it has gravity and mass affecting it and its properties. So it's obviously unified in reality somehow, but we don't know really how it joins up. But we're not talking about objects moving through a field like, that exerts force. We're talking about little ripples propagating off of it. So in the gravitational field, we're not talking about the mass moving through that gravitational field of the solar system. We're talking about the ripples that shoot out on that field, which theoretically should happen, and people are trying to find as a result of that motion. Okay, in the case of an electron, what we have is a shape like that. This is space, this dimension is space, and in this dimension it's what is the level of the quantum field. What is the level of the quantum field? And this packet is moving in the direction of the red arrow, so that in some future time we'll have the future state, and it'll appear to have continued to propagate that way. But what's really going on is, at this point, this field value is going up. That's the real motion. The real motion is this going up. And over here, for example, this level is going down. That's the real motion, that this field is going up and down like a rubber band. If you pull it up, or you just knock it upward, it'll shoot upward to a certain height, just like if you throw a ball up, then it'll shoot down. When it gets here, well, in most fields, if you want to have a negative space, it goes down, but in this one, it's sort of normalized to zero. You could draw this in a different space where the elasticity took it negative, but this is like an absolute value space. But the point is that this part of the field, it's going up, and this one's going down, and that's the real motion, up and down. The red arrow is just the apparent motion. Okay, when there's definitely, you need some things from particle ideas, metaphors for science, and wave both. But here's why one is more fundamental than the other when we get into material reality. Because I explain you seeing the particle as the fact that there's this wave, it's a shape, and you recognize the shape again over here. And it's like, oh, the shape is moved. But it's like a shadow that moves. The shadow doesn't actually move, it just is constantly reprojected into a new space. Right? It's the object casting the shadow that's moving, or the light source. So the real motion is up and down, and I can explain your particulate experiences and how it's really a wave. But you can't do it the other way around, because now it used to be that it would seem like to have a wave you needed particles, right? Because, for example, waves in water, there's particles there. And this elastic kind of a motion is that if you bump water particle, it goes over here, but then the pressure over here sloshes it back. But these turn out to be pretty non-idealized wave. There's friction, all kinds of loss, and it's, the speed of the speed depends on the wavelength, the speed of the water, because it's through a physical medium. And of course, they expected to find such a medium like this for light, the ether. And it would be at rest at some velocity. You could measure your speed relative to it, and we would find this ether. But it turns out there is no ether. What there is just the electromagnetic field, and at a lower level, the quantum field. And that's that's not quite like a medium because you're always at rest with respect to it. This creates the whole need for time warp and mass and uh, uh, distance warping because electromagnetic waves always travel at the same speed relative to you, no matter what speed you're going. So that's weird. So so it doesn't need particles. It needs fields. What are fields? Are fields made of particles? I don't know. It's some sort of rubber bandy thing where, that field wants to return back to zero. There's like an elastic behavior to it. So, and then when you disturb it, though, it does look a lot like a water wave, and conceptually, metaphorically, what's it really looks like electromagnetic, fields. You watch it on a meter, it looks like the meter's going up and down. But in the model, it is a little ripple, and it travels a lot like if you drop a stone in water, it travels out. So, yes.